My name is Catherine Renaud. Today I'll be presenting on configuring and hardening two critical protocols, IMAPS and DNS. These protocols are essential for secure communication and reliable internet access, making it important to understand how to set them up correctly and protect them from threats. Let's dive right in. In this presentation, I'll cover the configuration of IMAPS and DNS services across different server platforms. I'll also explain security hardening practices for each and how to verify the services are running properly. By the end of this presentation, you'll have a solid understanding of both protocols and how to secure them. Now let's start with IMAPS. IMAP stands for Internet Message Access Protocol Secure. It allows servers to securely retrieve emails from a server by encrypting the communication with TLS or SSL. IMAPS uses port 993, and encryption ensures that email messages aren't intercepted or tampered with during transmission. However, enabling IMAPS isn't enough. You need to harden the service to protect against attacks. But before we get to that, let's go over the basic configuration steps. To configure IMAPS on an Ubuntu server, we use Dovecot. First, we install the software. Once installed, we configure the server to require secure connections by enabling SSL. This involves editing a configuration file to specify that only encrypted communication is allowed. We also generate an SSL certificate to provide encryption. After making these changes, we restart the Dovecot service to apply them. You can test the setup by connecting to port 993 to ensure it responds. Now that the service is running, let's move on to securing it. The first security measure is disabling weak ciphers. Encryption algorithms like RC4 and DES are outdated and have known vulnerabilities. If these ciphers are left enabled, attackers could potentially decrypt traffic. By explicitly removing weak ciphers in the configuration, we block those attack vectors. Let's move to the next hardening step. The second hardening recommendation is enforcing TLS version 1.2 or higher. Earlier versions of TLS and SSL are vulnerable to several attacks, such as downgrade attacks, where an attacker forces a connection to use a weaker protocol. Requiring TLS 1.2 ensures that only secure protocols are used to encrypt communication. With this in place, we further reduce potential threats. Now on to our final recommendation for IMAPS. The last IMAPS hardening step is restricting network access. Not every system needs access to IMAPS. Typically, it's just internal or trusted clients. By configuring the server to only accept connections from specific networks or IP ranges, we reduce the risk of unauthorized access. With IMAPS secured, we'll now shift our focus to DNS. DNS stands for Domain Name System. It acts as the Internet's directory, translating human-readable domain names into IP addresses that computers understand. DNS typically uses port 53 for both TCP and UDP traffic. A compromised DNS server can significantly result in security risk, such as redirecting users to fake websites. That's why hardening DNS services is critical. But first, let's go over how to configure DNS on a Windows server. On Windows Server, DNS is configured using the DNS server role. Once installed, you can create both forward and reverse lookup zones. Forward lookup zones map domain names into IP addresses, while reverse lookup zones do the opposite. After creating these zones, you can add DNS records such as A records for host names and MX records for email servers. It's important to verify that these records are accurate, since any misconfiguration can lead to server outages. With that overview complete, let's look at how DNS is configured on Ubuntu using bind. On Ubuntu, we use bind, a widely used DNS server. First, we install bind through the package manager. Next, we configure global settings in a file named conf.options. This includes setting parameters for recursion and DNSSEC. We then define the DNS zones by editing the named conf.local file and create zone files for both forward and reverse lookups. After that, we restart the bind service to apply the changes. Now that DNS is configured, let's move on to securing it, starting with disabling recursion. Here we are. DNS recursion allows a server to query other DNS servers on behalf of a client. While this can be useful, it also opens the door to DNS amplification attacks, where attackers use your server to overwhelm a target with DNS traffic. Disabling recursion prevents unauthorized clients from using your server in these attacks. Let's move on to the next recommendation. The next step is enabling DNSSEC. This adds cryptographic signatures to the DNS records, allowing the clients to verify that the data hasn't been tampered with. DNSSEC protects against cache poisoning attacks, where attackers inject false DNS records. By implementing DNSSEC, you add an important layer of trust to your DNS infrastructure. Now let's move to the final DNS hardening recommendation. Zone transfers allow a DNS server to share its entire database of records with another server. While this is necessary for redundancy, allowing unrestricted zone transfers can expose your entire DNS structure to attackers. By limiting transfers to trusted servers only, we prevent sensitive DNS data from leaking. Next, I'll explain how to verify that both IMAPS and DNS servers are running as expected. To verify that our services are running, we use a tool called Nmap. This tool can scan a server to check if specific ports are open. For IMAPS, we can scan port 993, and for DNS, port 53. If the scans show that these ports are open and accepting connections, we know that our services are configured correctly. Now, let's move on to the final section. In summary, both IMAPS and DNS are essential services that must be secured to protect communication and network stability. Without proper handling and hardening, these protocols are vulnerable to attacks such as man-in-the-middle, cache poisoning, and amplification. Regular updates, secure configurations, and network access helps control and reduce the risk. Here are my list of references. To wrap things up, we've covered how to configure and secure IMAPS/DNS. We explored key hardening practices to protect these services and how to verify that they are running as intended. Thank you for your attention. If you have any questions, I'd be happy to answer them. Comment below.